Hi everyone, welcome to G World of Academy Physics. Continuing the model 5, that the concept of SHM and the time period of SHM. Here in the previous model 5 example, I consider a charge and which is displaced along the line. What will happen if you displace the charge vertically? Suppose this is the scenario. Two equal charges have been placed. Scenario is like this. This is the two equal charges at a distance of 2r apart. Any distance you can prefer. I prefer the distance 2r apart. Exactly where the equilibrium point? Exactly the midpoint. One charge, negative charge is placed. If I will place a negative charge and it is displaced vertically, a small displacement, it will displace a small displacement, you can say this is I am placing here, and it is displaced vertically like this to a point P of height y. It displaced to this point here. The question will ask you, if you displace a small displacement P at displacement y, then what is the time period of SHM? First, student must be think about, is the SHM will happen or not. If you observe carefully, this is now the final situation will be here. The final situation it displays to here. If you observe this carefully, this is positive, this is negative, it will be attract like this. This is negative and this is positive, and this charge will attract like this. If I will consider this angle is theta and this angle is theta, if this is theta, can I say this angle is theta? So what will happen? If this is the force, so this is F cos theta and this is F sin theta. Similar fashion, can I say this is F cos theta, because this is F, if this is theta and this is what? F sin theta. So what direction? We displace the charge like this. Again the charge is coming down because these two forces of equal magnitude and they cancel each other. And this force, the net force is coming this direction. It means we displace the charge upward and it is coming down to its again return back to its original positions. It means the SHM is happening, and we'll think about the time period of the SHM. What I said, when you displace the charge, when it reaches its final position, find the net force. And here what is the net force? And everybody can say F cos theta. F cos theta has cancelled. So the net force is what? F sin theta for due to this charge and F sin theta due to this charge. So what is the net force? The net force I can say that is F net. This is 2F sin theta. And what is the direction? Direction is minus y cap. So this is 2. What is F here? F is what? I will say K, Q, and I will say this is suppose small charge, giving two different charges. Take it like this, two different charges, K, Q, and this is Q upon what? This is 2R, means this is R, and this is y, so this is r square plus y square root over. So I will write as r square plus y square root over, and sin theta I will write at y upon, this is squares root over square, and this is r square plus y square root over, and this is minus y cap. I hope the scenario is clear to everyone. This is 2k q. This is square root over vanished, and this is 1 by 2, this is 1. Can I say r square plus y square whole to the power 3 by 2? Yes. And this is y. I will remove this negative sign here, and this is y cap. This is the net force. If you observe carefully, this is very similar to, and I will assume a condition that r is much more greater than y. It means our displacement here, looking it is very large, but the displacement is not that much of large. Very small displacement, in real sense it happens. That's why r is much more greater than y. So what is the scenario is 2kq. I can ignore this y. So r square, this is only rq y cap. This is the net force. I can conclude it. This is my net force. I hope the scenario is clear to everyone. Now, if you go for the SHM, this F must be equals to in the formula of here ky. So I'll write as ky or kx, anything I can write like this. If it is in horizontal direction x, it is in vertical direction, we can write as also F equals to ky. So what is the value of k? 2k q upon rq. This is the value of k. And what is the time period for the SHM? 2 pi root over of m by k. This is 2 pi, this is m, and I'll simply substitute the k value rq. This is the time period of SHM when the vertically will displace the charge. Let me analyze one more time. Two charges have been here. A negative charge exactly at the equilibrium point, and it displaces vertically to a small displacement y. The question will ask you, find the time period of the SHM. The student must have to think, is the SHM is happening? Yes. Why this SHM is happening? When you displace someone and it again return back to its original positions, one can say yes, SHM is happening. When the SHM is happening, always look at the final situation of the charge and write the net force on that final situations. When I write my net force, here F cos theta, F cos theta equal magnitudes but opposite directions, they have cancelled out. So F sin theta due to this charge, F sin theta due to this charge, 2F sin theta. As we are writing as a vector, so this is little carefully, we are writing everything with a vector. So 2F sin theta minus y cap. Just putting the value of these things and sin theta, we are observing this result, making a comparison, approximations we are using that the displacement is a small displacement, not that huge displacement that we are talking about. So it can be ignored. R is much more greater than y, so you just remove this y and the result is here, and making a comparison with the equation of the SHM that F equals to minus ky will get the value of k, and using the time period of the SHM t equals to 2 pi root over of m by k, I will simply substitute the value of k and I am getting the time period of the SHM. I hope the scenario is pretty clear. This is probably in your some of the good competitive exams, these basic models they may ask. I hope the scenario to clear to everyone. Thank you everyone for your watchings.